Section 4.2 Trigonometric Functions on the unit circle. This video explains how to use unit circle to evaluate trigonometric functions. It explains the periodicity of trigonometric functions. It explains the even and odd properties of trigonometric functions. What is unit circle? A unit circle is a circle of radius 1 and center at the origin. The point xy on the unit circle satisfy the equation x squared plus y squared equals to 1. Example 1 is square root of 2 over 2 comma square root of 2 a point on the unit circle. Well, to check that one, we will substitute the x equal to square root of 2 and y equal to square root of 2 in this equation x squared plus y squared equals to 1. So this becomes square of square root of 2 over 2 plus the square root of 2 over 2 equals to 1. Now we square the square root of 2 becomes 2, square root of 2 is 4. Similarly, square root of 2 is 2 and square root of 2 is 4. Now we have same denominator, so we can add the numerator, so we become 2 plus 2 over 4. 2 plus 2 is 4, 4 over 1, 4 over 4 is 1. So you can see left side is 1 and right side is 1, they're equal, so we can, the statement is true for this point on this equation. So we can say yes, this point lies on the unit circle. Trigonometric function. There are 6 trigonometric functions. This sign is read as sine, because this is read as cosecant, this is read as cosine, and this is read as secant, this is read as tangent, and this is read as cotangent. Definition of trigonometric function on the unit circle. Let P of x comma y be the point associated with a real number t measured along the circumference, real number t, from the point 1, 0 to point xy. Then we can define the trigonometric function as follows. Sine of t is equal to y. Cosine of t is equal to first coordinate x. So tangent t is y over x. Cosecant t is 1 over the y. Secant t is 1 over the x. And cotangent t is x over y. Trigonometric function of real numbers and angles. We know that the arc length s equal to r theta. If we set s equal to t and r equal to 1, then this equation s equal to r theta becomes t equals to theta radians, which means the unit circle, on the unit circle, the angle theta in radians is equal to the arc length t. So we can conclude that if theta equals to t, then sine of theta equals to sine of t. Cosine of theta would be the cosine of t, and tangent theta equal to tangent of t. Cosecant of theta is cosecant of t, secant of theta is secant t, and cotangent theta equals to cotangent t. Here's an example 2. So it says find the exact value of the sixth trigonometric function of the real number t. So we have this point on the unit circle, and its first coordinate is minus 8 over 17, and second coordinate 15 over 17. So from the unit circle, we can see x is minus 8 over 17, and y is equal to 15 over 17. And we also know sine of t is y, and y is equal to 15 over 17, so therefore sine of t is 15 over 17. Cosecant t is 1 over y, and y is 1 over 15 over 17, so this becomes 1 over 15 over 17, which means this is 17 over 15. Cosine t is equal to x, and x is minus 8 17, so the cosine of t is minus 8 over 17. Secant t is equal to 1 over the x, so it becomes 1 over and x is minus 8 over 17. So we become 1 over minus 8 over 17, which means this is equal to minus 17 over 8. Tangent is y over x, and y is 15 over 17, and x is minus 8 over 17. So this becomes 15 over 17 times the reciprocal of 8, 17 will be minus 17 over 8. 17 cancels and gives you minus 15 over 8. Cotangent is x over y, and x is minus 8 over 17, and y is what? 15 over 17. So it becomes minus 8 over 17 times 17 over 15. 17 cancels, the answer becomes minus 8 over 15. Unit circle. If you divide the unit circle into 14 equal parts, so we have this one, it's pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, 7 pi over 6, and 9 pi over 6, and so on. So for every angle, pi over 6, for example, is an angle, and this corresponding point is square root of 2 comma 1/2. So if we know the angle from the corresponding point, we can find the cosine value and the sine value. So you can use this unit circle to find cosine of any angle which are on this unit circle. So here, example 3, so we have t is equal to pi over 6, and if we want to find the values of sine, cosine, and tangent. So you can use this unit circle to find that one. So let's look at t is equal to pi over 6 on the unit circle. So that's a pi over 6, and this is a point on the unit circle. Its coordinates are square root of 3 over 2 comma 1/2. So the first coordinate is x, the second is y. So we have a point x comma y, square root of 3 over 2 comma 1/2. Now sine pi over 6 would be, we learned it's a y, and y is 1/2. So the answer is 1/2. Cosine pi over 6, cosine is equal to x, and x is square root of 3 over 2, and that's basically it. So similarly, we can find the tangent, and tangent pi over 6 y over the x, and y is a 1/2, and the x is square root of 3 over 2. So now we can write 1/2 and multiply the reciprocal of this one, which is 2 over the square root of 3. 2 cancels out, and get a 1 over the square root of 3. Now we rationalize. We multiply top and bottom the square root of 3. So we have 1 over square root of 3 times square root of 3 over square root of 3. Now square root of 3 times square root of 3 becomes 3. So your final answer is tangent pi over 6 is square root of 3 over the 3. Example 4. We have t is equal to negative pi over 6, and we want to find the values of sine of t, cosine of t, and tangent of t. Since the circumference of the unit circle is 2 pi, the value of t minus pi over 6 and t equal to minus pi over 6 plus 2 pi will have the same value, 11 pi over 6. 11 pi over 6 right here. Okay? Or you can go this way, pi over 6, so that's 11 pi over 6. And the corresponding point is square root of 3 over 2 minus 1/2. So x is then square root of 3 over 2, and y is the square root and minus 1/2. So sine minus pi over 6, we know sine is equal to y, and y is negative 1/2. Cosine negative pi over 6 is x, and x is square root of 3 over 2. Tangent negative pi over 6 y over the x, and the y is negative 1/2, and the x is square root of 3 over 2, which means negative 1/2 times the reciprocal of this one, which is 2 over square root of 3. 2's cancel, gives you negative 1 over square root of 3, and then we can rationalize, and you'll get negative square root of 3 over 3. even and odd trigonometric function. From calculus 1, function f of t is even if of negative t is f of t, and it is odd if f of negative t is negative f of t. So the cosine and secant functions are even, and therefore cosine of negative t is cosine of t, and secant of negative t is secant t. The sine, cosecant, tangent, and cotangent are all odd, which means sine of negative t is minus sine of t, cosecant of negative t is a minus cosecant of t, tangent of negative t is a negative tangent t, cotangent of negative t is minus cotangent t. Example 5. Use the given value of sine of t equal to 3/4. Find sine of negative t. Well, sine is, as we said earlier, is the odd function. So sine of negative t is minus sine of t. And sine of t is 3/4, so the answer is negative 3/4. Example 6. So sine of t is 3/4, so we want to find cosecant of negative t. So given is sine of 3/4, so by definition, y is equal to sine of t is equal to 3/4. And cosecant is 1 over y. So y is 3/4, so 1 over 3/4 becomes 4/3. Since cosecant t is odd, so cosecant of negative is minus cosecant t. So we just found cosecant t is equal to 4/3. So the answer is negative 4. So basically, first we find the cosecant t from the given sine of t. And then we find the cosecant of negative t, and we apply the odd property, and then we replace cosecant t value for it. Example 7. We are given cosine of negative t is equal to minus 1/2. We're going to find the cosine of t. So we can start with the cosine of t is the cosine of negative t because cosine is odd. Cosine is even. So cosine of negative t is given negative 1/2. So we replace minus 1/2. So the cosine of t is equal to negative 1/2. Example 8. Cosine of negative t is minus 1/2. And we need to find the secant of negative t. So when cosine of t is even, so we know that cosine of t is equal to x, or you can say x is cosine of t, and this is equal to cosine of negative t because cosine is even. But cosine of negative t is given negative 5, so we write negative 1/5. Now we're going to find the secant t of negative t. So secant t is also even. So we write secant of negative t equal to secant of t. Secant of t is equal to 1 over x, and x is negative 1/5. So it becomes 1 over negative 1/5, which means 1 times negative 5 over 1, which means negative 5. Example 9. The displacement from equilibrium of an oscillating weight suspended by the spring is given by y is equal to 1 over 2 cosine 6t. Y is the displacement in feet and t is the time in second. Find the displacement t equal to 0. So t is given, we have to find. So we start with this equation, y equals to 1 over 2 cosine 6t. I may substitute t equal to 0. So this becomes 1/2 cosine of 6 times 0. 6 times 0 is 0, so it becomes 1 over cosine 0. Now we can put on the calculator and in radian mode, and we just find cosine 0 is 1. Or you can also use the unit circle. From the unit circle, cosine of 0 is x, and on the x-axis, the x is what? 1. So final answer is 1/2 times 1 is 1/2. Okay, example from the equilibrium of an oscillating weight suspended by a spring is given by y equals to 1 over 2 cosine 6t. Again, y is the displacement, t is the time in second. This time t is 1/3. So again, we start with y equals to 1/2 cosine 60, and we substitute t equal to 1/3. We simplify, gives you cosine 2. Now this 2 is in radians. So you have to get scientific calculator used and make sure the calculator is in radian mode. And we enter the angle and press cosine 2, or you can enter cosine and press the 2 and then press enter. You should get negative 0.2081 and then round to 4 decimal places. Periodic function. A function f of t is periodic if there is the smallest positive number c for which the function repeats itself. So mathematically speaking, f of t is periodic with a period c if f of t plus c is equal to f of t. So sine of t is periodic with a period of 2 pi because sine of t plus 2 pi is a sine of t. Cosine of t is periodic with a period of 2 pi because cosine of t plus 2 pi is cosine of t. Similarly, tangent t is periodic with a period of pi because tangent of t plus pi is tangent t. Example 11. Evaluate sine of 9 pi over 2 using the periodic period of the sine function. So let's rewrite 9 pi over 2 is equal to, if you divide 9 to 4, it becomes 4. So 4 pi plus pi over 2. So now we rewrite sine 9 pi over 2. So sine 9 pi over 2 becomes sine of 4 pi plus pi over 2. So basically you're going to go 2, make 2 circles, and you get, again, you come back to sine pi over 2. Now you can use a unit circle, and on the unit circle the point is 0, 1, and sine is y, and y is 1. So sine of 9 pi over 2 is 1. Example 12, we're going to find the value of cosine of negative 7 pi over 2 using the period of sine function. Well, first of all, we have a negative angle, and we can apply the even property of the cosine. We know cosine of negative 7 pi over 2 is the same as cosine 7 pi over 2. Now we rewrite this one, 7 pi over 2. If we divide, it becomes 3 pi plus pi over 2. And we can just break it down into 2 pi plus pi. We can add pi into pi over 2, which becomes 2 pi plus 3 pi over 2. So now we have this equal to cosine of 2 pi plus 3 pi over 2. Now cosine is periodic and it repeats, and its period is 2 pi. So this simply equals to cosine of this angle, 3 pi over 2. Now we can go to the unit circle. Point x comma y is 0 comma negative y, and we know cosine 3 pi over 2 is x, and x is 0. So the answer to this question is the cosine of negative 7 pi over 2 equals to 0. So that's the end of this video. So please make comments after going through this videos, and if you like it, you can subscribe to this video.